Hi students, this is Mr. Epperson, and this lecture is on how scientists measure things using what's called qualitative and quantitative data. So, like I said, there's two types of data. One is quantitative, the other is qualitative. And let's define those terms. So quantitative data, deals with what's called quantities. And a quantity, if you think about buying something online, you're going to buy a certain number of those things. Maybe you're going to buy, two pairs of underwear or something on Amazon. And when you buy that item, you can either buy one or two or three or four. Usually we just buy one of things because it comes in a pack or something, but even that's a quantity. A number is just how many of something you're getting. Qualitative data is, qualities about things and what we might just call descriptive data or categorical data. And so categorical data can look like a lot of things. I'll tell you about a couple different types of examples here. To go back to quantitative, though, there's really two sort of camps of numerical types of data. And there are sort of a couple of different ways that we might explain these. One is called discrete data, and the other is called continuous data. When we're calculating or I guess when we're using discrete data, it's really what we're doing is we're just counting stuff. And that's a little more complicated than it sounds, but it's actually not too bad. When we're using continuous data, that's anytime we're actually taking a measurement and using a tool usually. So I'll give you some examples for that. If we're using what's called qualitative data, we're basically using what we can gather with our five senses. Anything else that's not from our five senses, that we're not gathering just from, smell, taste, touch, feel, sight, any of those things, we can gather qualitative data just by putting something into a category, like a mental category. So I'll give you again some examples for that. So let's do some notes on the different types of data that we can get. Let's start with the discrete category. Whole numbers is really what defines this category. Here are some examples. 3 dogs, 1,000 births. How about 350 COVID cases? Okay? Those are different types of discrete information, data information. They're numbers, but they can't come in any other smaller quantity or larger quantity than these whole numbers. So if I was counting the number of dogs that were playing at a dog park, and I was taking that information to see, how popular that place was for people and their dogs, and I count 3 dogs in an hour, I would get information, but I can't have 3.5 dogs, right? That would be, that wouldn't make any sense, or be kind of funny if that data would work, right? That you can't have half a dog. You also can't have half a birth, right? You can't have 1,000.5 births or 0.55 births or any of that for that matter. You can only have whole births. And the same with a COVID case. You can only have either it's a case or it's not a case. Like it's a yes or it's a no. So these things exist in whole numbers. So that's discrete data. So what about continuous data? I'll give you some examples here. 95 milliliters. 5 centimeters. 20 seconds. Let's go with this one for now. If something is being measured with seconds, the way that you've captured that is with a stopwatch, right? So you might have a stopwatch and it's got a little timer in it. And as it's going on through the stopwatch, all the little ticks will tell you how many seconds have gone by, right? This is kind of an old style stopwatch, but you get the idea. And if it gets to 20, well, you know that 20 seconds have gone by, and the little stopwatch will have counted all the way around. But there were numbers in between here. 1, 2, 3, 4, 5. It was counting all the way. It was continuous information. And let's say you took a data point at 20, and let's say again you took a data point at 40, and then at 60, and then at 80, right? You could take data all the way around and continue taking that information. And if you were to graph that out, it would be correct to say that, you have a data point at 20, one at 40, one at 60, and one at 80. And if you were to graph whatever would be on the y-axis, doesn't matter for now, you could have your data points laid out like this. But what's important about the graphing part of discrete versus continuous data, the discrete data, you can't assume that something happened in between these two lines because you didn't actually take the data there and it wasn't a continuous point A to point B kind of bit of information. So you can't assume that you know what goes on in between these 2 points. But because you were taking data the whole time, you started here and then you took another point here, you can assume that whatever happened in between these 2 points, the data would look like that if you had recorded it. You could sort of guess that that is what happened. It probably didn't go like this, right? That would be some weird information. It could, but you're assuming it doesn't. And it's the same thing between 40 and 60 and between 60 and 80. And that's why we tend to like to connect the dots between bits of data, because when we do that, what we're doing is we're assuming that we know what happened in between the steps. We didn't take all of the data points. We didn't take it for every second, but we assume we took enough information that we know what happened between here and there and all the way in between. So continuous data is very, very important and helpful, and it's some of the best, highest quality data that you can take. But these doesn't mean that the other types of data aren't valid or good. Discrete data, sometimes that's all you can do. Continuous data, that's what we do. That's why we use good tools and good measurement techniques. The census-based data, well, this is anything that you would expect, right? This is like your sight. This is hearing and smell, and the 5 senses. But anything that can come through these 5 senses, touch and taste, could be recorded in a data set, but you don't have any numbers attached to that. And that's why we'd call them qualitative. They're categories of information. So you might say, something exploded and you saw light, right, come out of it. You might have heard a sound, right, like a bang. You might have smelt some smoke and felt it and it was hot. And, maybe we wouldn't want to taste whatever just exploded. But you get the idea. There would be different types of information that you can pull from an experiment and put that in qualitative analysis. But you may be wondering, what about other types of data? Well, for instance, what about male and female? That's data, right? If somebody claims male or female, that kind of information would go into your study. And you would be able to come up with some information about that. And so you might say, well, how many people are getting COVID? So I'd have my number of cases, but I'd break them up into male and female categories. And I might say, well, the number of males is, this high, and the number of females is this high, and I could compare them. But in this case, my variable down here is male or female, and then my variable over here is how many COVID cases there are. So in this way, it's important to know which types of information, because that actually ends up determining what graph you draw. So learning the different types of data that we'll collect or that would be necessary for whatever experiment you're running is very important. Let's go ahead and do a little quiz. 23.4 centimeters, is that qualitative or quantitative? And if it's qualitative or quantitative, which of the subcategories is it? Well, it's a number, right? So it's quantitative. It's also continuous because it's a measurement. You're using a tool for that, a ruler. How about 7 people were saved from a burning building? Qualitative or quantitative? It's quantitative, right? It's a number. But is it continuous or discrete? It's discrete, right? Because you're only able to count whole people. You can't count half a person who was saved. How about an experiment and we're saying experiment number 2, if we're like numbering them out, made a small explosion. What type of data is that? Small explosion. It's qualitative data because there's no number attached to it, right? We had experiment 2, but that was just labeling which experiment it was. The data was that it exploded, and you're using your 5 senses. So it's kind of in that category. How about test 2 number 9 turned white? That's more realistic to what we would do in class. Qualitative, again. And again, using your 5 senses using sight. Okay, somebody is measured as a 6 foot tall person. Qualitative or quantitative? Continuous or discrete? I might have tricked you on this one. It's continuous quantitative data. And the reason it's continuous is because you're measuring from floor to ceiling, from floor to their head, I guess, how tall that person is. And all of the data in between still counts. So you call that actually continuous data because, again, it's using a tool, it's a measurement. So continuous. Last one. The first semester of school. This one's kind of tricky, but it's actually qualitative data because just because it's the first semester, there are ways that we might put this in a way that it sounds like you're counting, but because it's just a label, it's just another category. We actually call this ordinal data. There's more statistics that you can take, and you'll learn about ordinal versus nominal. So this would be ordinal data, but that's not as important right now. But really, just because it's a label, and it doesn't really have to do with the number itself, more just that it's a part of the school year, we would actually consider it qualitative data and one of those other categories. It's not a 5 senses, but it is something that you can state about that time of the year. Okay. Well, I hope that you've learned the difference between qualitative and quantitative data, and I hope that that was helpful for distinguishing between the two.